Okay, this is pre-calculus, notes 7.1, 7.2, day 2. And this is where you're going to be solving systems of equations, but you have to set them up. And so we have, the first step is to label your variables. And then the second is to set up your system. And the third is to solve, and don't forget units in your answer if they are if they need to be there. So example 1, you have 25,000 invested in two funds, one paying 7% and one paying 4%. The yearly interest is 1,405. How much is invested at each rate? So I'm going to label variables. I'm going to let X be the amount at 7%, and I'm going to let Y be the amount at 4%. And so one of the equations I have is X plus Y adds up to 25,000. That's how much you have invested. To get the fact that the yearly interest is 1,405, I need to use this formula. Interest is equal to principal times rate times time. And so for the 7%, the amount of interest you're going to get is amount of principal is X, the rate is 0.07, and the time, it is the yearly interest for it's yearly interest, so it's 1 year, or 0.07X. And that's the amount of interest you get from the 7%. The amount of interest you get from the 4% is the amount invested, which is your principal of Y, 0.04, and then it is for 1 year, and you have 0.04X. And so if I total those two amounts, oops, back here, that should have been a Y. And so 0.04Y, that adds up to the 1405. And so that's your system, and that's what you need to solve. And if you want, you can multiply that second equation by 100 on both sides so that you get rid of the decimals. You don't have to, though, because you do have calculators. And then it's just up to you in terms of how you want to solve that. If you want to go ahead and solve by, say, substitution, then you can go ahead and X is 25,000 minus Y, and then substitute that in. And so if you distribute the 7, that's 175,000, excuse me, minus 7Y plus 4Y. And then from there, continue to solve. And I am looking for my calculator, sorry. If we take the 175 minus the 140,000, you're going to get 34,500. And minus 7Y plus 4Y is a minus 3Y, but move that to the other side. And if we divide that by 3, we get Y at 11,500. And then to find X, come up here and subtract that 11,500. And X comes out to 13,500. So you should invest 13,500 at 7% and the 11,500 at 4%. So in example 2, we have the small business that has an initial investment of $6,000 and the unit cost of the product is $23.20, yet the selling price is $35.20. How many units must be sold to break even? And break even is when the cost equals the revenue. So what you're bringing in is the cost to make everything. All right, so profit here is also what you bring in, which is your revenue, minus your cost. Those are some things that are handy to know. So in this case, my cost, well, you have to pay $23.20 times the number of units. So I should say X is going to be number of units. But you also had that initial startup cost of $6,000. And then your revenue, you are selling each one for $35.20. So that's the revenue that you are bringing in. And as we said, break even is when cost equals revenue, so we are just going to set the two of these equal. And solve. So subtract the 2320. And if I divide by 12, I need to sell 500 units. And we will break even. Example 3. From 2001 to 2012, the population of City A was increasing at a faster rate than was the population of City B. Models that approximate the two populations in thousands are given to you. And if you notice, the slope on the first one is 95, while the slope on the second one's 41.4. That slope being 95 is your faster rate, so this must be for City A, and the second one must be for City B. And T represents the number of years since 2001. You have to be a little bit careful because if T is 1, it's not year 2001, that is, excuse me, year 2002. If T is 2, that is going to be 2003 because at T being 0, that is for year 2001. So T is the number of years since 2001. Be a little just careful on that one. So according to these two models, when would you expect the populations of these to be equal? Well, this is your system. And they're both equal to populations in thousands, so you just end up setting them equal to each other and solving for time. And as you solve that, if I subtract the 41.4, I have 53.6 T here. And subtract the 4,900 from the 5,118, you get 170.7. And if I divide that, I get about 3.1847 is that time in years. That rounded to the nearest tenth is 3.2. And so I think about T being 3.2. Whoops, I forgot to finish this one. For 1 year, it's 2002. For 2 years, it's 2003. So we're really adding 3 point to 2001, and so that would be 2004.2. And so when do you expect the populations to be equal? Round to tenths. In 2004, approximately 2004.2. Which, if you figure that out, it's somewhere in the third month, somewhere in March, maybe around the 7th or 8th day of March. All right, so in example 4, we have an airplane flying into a headwind, and it travels this 1,650 miles between two cities in 3 hours and 18 minutes. So it takes 3 hours and 18 minutes to fly one direction, and that's a total of 1,650 miles. And then on the return flight, it has the same distance to fly, 1,650 miles, but it only takes 3 hours. And that's because there is either a headwind or a tailwind. And so it says find the airspeed of the plane and the speed of the wind. So I'm just going to let x be the airspeed of the plane. And I'm going to let y be the wind speed. And so when I'm looking at this, I need to remember rate times time equals distance. But I've got to think about headwinds and tailwinds. And if you have the airspeed of the plane, but it's flying into the wind, it has a headwind, and that's what happens on the way there because it takes longer. You subtract the wind speed because it's going against it, and that's the rate with a headwind. If I have x plus y, that is your rate with a tailwind. And so over here, my rate on the way there is x minus y, but my time is 3 hours and 18 minutes. Well, we've got to change that to just hours, and 18 minutes out of 60 would change that. It's 18/60th of an hour, which is 3 plus, if you reduce that, we get 3/10. We chose a convenient number of minutes because it's exactly 3.3 hours. So on the way there, it takes 3.3 hours at the rate of x minus y to get that distance. On the way back, the rate is x plus y, and it takes 3 hours to go that. So that is your system. So it's just how you want to go ahead and solve it. If I distribute the 3.3, if I distribute the 3, and then that second equation, because right here, 1 plus 6, oops, that's supposed to be a 6, plus 5 add up to 12, and that's divisible by 3. 1,650 is divisible by 3. So I can actually make that second equation a little bit simpler. By dividing it by 3. And I get x plus y is equal to 550. And then it's just a matter of how you want to solve it. If I say x is 550 minus y and substitute it into the top equation, and then if I distribute this, so here I've got a minus 6.6y. And if I take 1650, oh, I wrote this down wrong. This should have been 1815, sorry about that. The 1650 minus the 1815, I get 165. And it's negative. And so if I divide that, it comes out to a nice, neat 25. And y is the the wind speed, so 25 miles per hour is my wind speed. And then right here, x is 550 minus 25. which is 525, and it will be miles per hour, is my air speed of the plane. Lastly, point of equilibrium of the supply and demand equations. We have a demand equation and a supply equation. And equilibrium is simply when the demand equals the supply. And they're giving you the demand and the supply equations. So we want to know when they are equal. And note P is the price in dollars and X is the number of units. So since they're both equal to P, I can just set them equal to each other. And I've got what? 5.675x. And that comes out to X is 120. So that should be the number of units. And we can figure out the price per unit. By taking 120 times 0.125. And it comes out to 1536. And that's it.